Today we're going to take a look at a plane mirror and reflections off a plane mirror. Now in physics, when we say plane mirror, we're talking about the two-dimensional geometric plane. So this mirror has a reflected surface in front. You can see my hands and my phone down there. And in back, nothing, just to support to hold it up. And things you already know about a mirror, plane mirror. If I put an object in front of the mirror, my little frog with his top hat on, you see the image behind the mirror. And as you know, if I put my object closer to the mirror, the image moves closer to the mirror. If I move my object further away from the mirror, the image moves further away from the mirror. Any object I'd put in front of the mirror will cast an image behind the mirror. We call this image a virtual image because there appears to be things behind the mirror. But in fact, as we know, there's nothing back there. So it appears to have an image. We call that an apparent image, or more technically called a virtual image, as opposed to a real image, which we'll be looking at probably next week. Not only is the image behind the mirror, but it's got to be equidistant behind the mirror. If you take a look in your notes at page 162, we post lab from the Ripple tank, the water lab, and down at the bottom we sent in circular waves. They bounced off the mirror and we saw circular waves coming back, but more importantly we said the circular waves are looking as if they originated behind the mirror, the same distance that the actual waves were sent in front of the mirror. How that relates to this is I'm going to take another object. Here's a water bottle. It's nice berry flavored water. And I see the image behind the mirror as I should. I'm going to take another bottle, same bottle, and I'm going to put it equidistant behind the mirror as best I can. Probably about there or so. And if I look down and if I put it exactly equidistant behind the mirror, you notice that the image in the mirror and the object behind the mirror are located in the same spot. I can go back and forth, up and down. It looks like it's one in the same bottle. That bottle is located equidistant behind the mirror as the real bottle is in front. Now if I put this bottle in front of the, and it's not equidistant, obviously you don't get the same phenomena. If I put it too far back, obviously not the same phenomena. But if I only can put it right equidistant in front of the mirror, it looks like it's the same bottle. So again, this is called a virtual image. It appears to be there, but it's not really there. I'm going to show you how this happens, and it uses the law of reflection. Technically, what we're seeing is not a reflection. Technically, what we're seeing is an image, and the image is caused by the reflection of light off a mirror. So here's an object, my frog in his top hat again, in front of the mirror. And I'm going to use a marker and just draw a basic circle where that frog would be. So give me a second here. And label that object. I already have a line drawn where the mirror would be. So that would be my mirror. I'm going to show you what happens in terms of the law of reflection. So back here, equidistant, is where the image is located. Now with the laser, and this is an actual lab you guys were going to do this year, but obviously with the coronavirus, probably not going to happen. My laser is going to show the law of reflection. So I'll use my chess piece here. And you should be able to see the laser light going in and hitting the chess piece back behind the mirror. But obviously what the laser is really doing is bouncing off the mirror and hitting the real chess piece. So if I line it up to see the image, it's actually hitting the object. And that shows us the law of reflection, as I'll show you in a second, with the angle of incidence equals the angle of reflection. So imagine my eye is over here someplace, and I'll draw my eye looking back behind the mirror. There's my eyelashes, my pupil, looking back behind the mirror. So as best I can draw straight hand, freehand, I'm going to draw a line that goes straight back to the image. That line's called the line of sight. It's the line I am seeing along. It's my sight line. But obviously light's not penetrating through the mirror. What's happening, I'm going to draw with another line right along that line of sight. And then when it hits the mirror, I'm going to reflect it back to the actual object, that chess piece. And that path is called the optical path, which means light path, the true path of light. If I draw a normal line right there, we can see that the angle of incidence equals the angle of reflection. And technically that is coming from the object, incoming or incidence against the mirror, then bounces off the mirror and reflects into my eye. And that's what the laser would show us in the lab. So the light looks like it's going back behind the mirror, but it's really bouncing off and hitting the chess piece. And again, that's called a virtual image. It appears to be there as opposed to a real image, which we'll be looking at in the very near future. Hope that made some sense for you guys. I miss you all.